Alright, so first we're going to go over the area of triangles. The general formula for an area of a triangle is 1/2 base times height, where height is a perpendicular distance from the vertex to the base. If you're given all three sides, then you can do square root of semiperimeter times semiperimeter minus a times semiperimeter minus b times semiperimeter minus c, and the semiperimeter is just half of the perimeter. If you're given two sides and an included angle, you can use 1/2 times a times b times sine of c. So you can think of it as a times sine of c is equal to the height, so you're just substituting that in if you don't have the height itself. If you're given two angles and an included side, then you can use a squared times sine b times sine c over 2 times sine of b plus c. And if you have an equilateral triangle, then you can use square root of 3 times s squared over 4. Alright, now we're going to go on to the area of a quadrilateral. So first we're going to talk about the area of rectangles and parallelograms. The area of a rectangle or a parallelogram is going to be base times height. Height is a perpendicular distance from one base to the other. A rhombus or a kite is going to have an area of 1/2 times diagonal 1 times diagonal 2. So the diagonals are multiplied together, then divided by 2. The area of a trapezoid is 1/2 times height times base 1 plus base 2, and the area of a square is s squared, or the side squared. The area of a regular polygon is equal to 1/2 times a times p, where a is the apothem and p is the perimeter. So, first of all, a regular polygon has some special measurements. It has a center, which is also the center of the circumscribed circle. The center is equidistant from each of the vertices and each of the sides. The distance from the center to the vertex is called the radius, and the distance from the center to the side is called the apothem. If it's a regular polygon, then the radius is going to bisect each of the interior angles, and the apothem bisects the central angle, which is formed by two radii. The apothem also bisects the side. And you can see that the apothem and radius form a right triangle, so you can use the trigonometric ratios in order to find out these measurements. So since the central angle is equal to 360 divided by the number of sides, and the apothem bisects the central angle, then the top angle is going to be 1/2 the central angle, while the bottom angle is going to be 1/2 of the interior angle, since the radius bisects the interior angle. And you can just use trigonometric ratios in order to find the apothem, or the radius. Alright, so a sector is basically a part of an area of a circle. So a sector is formed by a central angle and its arc. So it's just a portion of a circle, like a slice of a pie. A segment is formed by a chord and its arc, so it's an even smaller part of a circle. So it's like this little green segment right here. So in order to find the area of a sector, you just take x over 360 times pi r squared, where x is the measure of the central angle. To find the area of a segment, you just take the area of a sector minus the area of a triangle, since you can see that a segment basically is just a sector minus this little triangle part right here. So if that was the whole sector, you just need to take away the triangle in order to get just the segment. Finally, we're talking about similar figures and scale factors. So if two similar figures have the scale factor of a over b, then the ratio of perimeters, or any one-dimensional measurement, is equal to a over b. The ratio of area is equal to a squared over b squared.